All right, everybody, this is Chapter 3, Dimensional Analysis. So when it comes to this class itself, it's kind of like, if you've taken a chemistry class before, it's about the same kind of concept. All we're going to do is just conversions. That's all we're going to do the entire semester is conversions, conversions, and conversions, okay? So just give you guys a little background information. What it means by dimensional analysis is, well, just to think of one, equivalency when it comes to it. So for instance, just start from the basics, let's suppose we have, let's see if this is 7 over 7. Oh, these both don't work. Oh, there we go. Okay, so what does that give us? So 7 over 7 gives you 1, right? Okay, so we all know that one. So let's go a little into the algebra portion. What about x over x? That also gives you 1, right? Because, there's like 7 over 7, they cancel each other out to give you 1. Right. So same concept when it comes to this portion is when it comes to unit-wise, so it's going to be the same thing as we talk about the x values themselves. So for instance, we have 7x over 7x, that still gives you 1, right? Because again, for the individual portion, 7 over 7 gives you 1, and x over x gives you 1. So essentially what we're doing is we want to cancel out the units themselves to begin with. So in our case, instead of variables, we're going to have units. So, a unit could be, miles is a unit, hours is another unit, and so forth. Right? We have, a lot of type of units when it comes to it. Okay, so that's going to kind of abbreviate down here where it says, so we're taking about the units of measurements like feet, 4 feet, 5 inches, and so forth, and we can treat these units as if they're a variable. That's a key thing, right? So when it comes to units, treat them as a variable, meaning they simplify just like that. Okay, and apply the same cancellations. But instead of saying variables, we say the units describe the labels of feet, inches, and ounces, etc. So for example, right, we have 7 days over 7 days equals 1. Because again, because the 7 over 7 cancel out, and the days over days cancel, just like x over x cancel to 1. So that's what it means. So you basically, for the entire semester, whenever you see a unit, treat it as a variable, and you can cancel it just like a variable itself, okay? So, and then I describe it what's actually happening here, okay? So based off that concept, we want to call something called an equivalency, okay? So an equivalency is an expression that describes the same quantity in different units. So for example, right, well, there's 7 days in 1 week. So that's called an equivalency. 1 week equals 7 days, okay? And there's a couple more equivalencies you guys probably know right off the bat of yourself, right? You can even look at the clock system for our case, right? Focus. There you go. So the clock system, right? We know there's, 60 minutes equals 1 hour, right? So that's one other equivalency we have just by the clock system as well, right? We also have like 24 hours equals 1 day. So there's multiple stuff we do when it comes to the equivalencies. Now the thing is, when it comes to an equivalency portion, there's a couple ways I can write this. I can write this like this, where the equal sign equals that, or I can bring it into division symbol, making it look like that. So we say 7 days per is basically 1 week equals 1. So just bringing it over. So in our case, we're going to use our equivalency using as fraction format. Okay. So what this says is 7 days per 1 week. So that the division symbol means per whatever it's going to be on the bottom. Now the thing is, we can flip-flop it. For instance, if I flip the weeks and days, that's still true, correct? 1 week per 7 days, that is technically true, right? Because in 1 week there are 7 days. So the key thing when it comes to equivalency is I can flip-flop them top and bottom, and they mean the exact same thing. The reason why we care about flipping back and forth is, again, once we start canceling units-wise, as we're going to be choosing one or the other to actually simplify using our equivalency itself. Okay. All right, so now we're just going to quick little list of other equivalencies we're going to be using in this next couple of chapters is these ones here. Also, you may want to start remembering. Well, you guys are going to be in your class houses anyways, but just giving notes when it comes to the abbreviations as well. Okay. Okay. So for instance, inches is IN, foot is FT, and so forth down the line, right? When it comes to it. All right, and I'll slowly transition to you guys so you could see, portions of it. But eventually you guys are probably going to memorize a lot of them, just, practice on the homework and stuff like that as well, okay? So here's our, mostly our equivalencies we're going to be using for this section or next chapter and move forth. So let's just do a couple examples, right? So first example, let's say we want to convert 35 years to, let's say, months. Okay. Now, whenever you want to do a conversion factor, again, if you guys remember in a little bit of chemistry, is you always want to start what you're given. So, right, we're given 35 years. So this is a given. And you always want what you want. And we want months. So somehow at the end of this calculation, our notation should be months, right? MON for short, months. Now we always start what you're given. So we're given 35 years. So I'm going to abbreviate years as YR. We're always going to put over 1. Now the thing is, when it comes to a conversion, is you always want to multiply by some equivalency to get to what we want. Okay. Now, instance, right, we've got to figure out, given our equivalences here, which one associates a years to months. And hopefully you guys all see this one, right? We know there's 12 months in 1 year. Okay. Now this is where I'm talking about, we got to figure out which one goes on top and bottom, right? So let's focus real quick. Q. This will focus. Thank you. So now, here's the question. Does years or months go on the bottom? Now remember, we want to actually cancel out years, just like we did this way here, right? When we multiply, top and bottom cancel each other out. So here's the thing. If, let's suppose I put years on top. So if I know for every 1 year, they are 12 months, right? Suppose we did that. Well, if we multiply, right, just like multiplying anything, we have 35 times 1, which is 35, and years gives you years squared, just like, an exponent, right? X times X gives you X squared back in algebra. So it doesn't cancel out years. And at the bottom, well, 1 times 12 is 12, and this gives you months. Notice, I just want months, not years squared over months. So that way you can check yourself, okay, this didn't work, so therefore I actually have to flip it. So if we flip it now, we get 12 months on top and then years on the bottom. Now notice the years do cancel, right? They literally cancel from there. And now we multiply across, so this should give me a pretty big number. Let me get the calculator. 420 months. Okay. And that's how we do conversions. Just that's it. And we got to figure out what's we're given, so put that there, and then multiply by some equivalency to get exactly what we want. And all the job is now figuring out, how the equivalency is actually going to be. Is it going to be flip-flop? And, what the units are going to be on top or the bottom itself. Okay. So let's try another one. Let's do a next one here. Let's convert, let's say, 5,400 seconds to minutes. All right, so always start what we're given. So we are given 5,400 seconds. And again, we had to multiply by something to give us minutes, right? MIN for short. Now again, right, we got to multiply by some equivalency that gives us from seconds to minutes. And hopefully everybody knows this one, right? There are 60 seconds in 1 minute. Now again, the same question becomes, well, what am I putting on the top? Is seconds going to be the top or the bottom, right? Based off that. So again, right, since seconds starts on top, and the only way to cancel it is to go on the bottom, so therefore, if it's easier, always put your units first, so you know exactly what's going to happen, then plug in the numbers associated, right? So 60 goes next to the second, so that's going to be 60, and then 1 goes on top, and therefore this time we have to divide instead of multiplying like we did last time. So this gives us 90 minutes. Okay. All right, so just say we have like a part B question to this. What if now we want to go a little farther? So let's say like this is part A, and then part B now says, well, what if I want to go from now minutes to hours? Okay. Well, start with the given, so 90 minutes. And again now, what equivalency tells us goes to hours? Well again, right, we know there are 60 minutes for every 1 hour. Now again, the question becomes what goes on top and what goes on the bottom. So hopefully it's going to be the same process, right? We want minutes on the bottom because that cancels out, hours on top. Now we plug in the actual numbers, 60 minutes for every 1 hour. So again, we divide. So 90 divided by 60 gives you 1.5 hours as your answer. Okay. So this is the process we would do if we actually started from seconds and asked to go all the way to hours. Notice that we have to do it twice. One conversion to minutes, and then another conversion to hours. So that's called a complex conversion, because now complex means you're going by two-step process when it comes to equivalency. So you're using one equivalency here and another equivalency as well. So that's called a complex portion. Okay, so let's go to the next page. Now let's talk about what happens when we have fractions instead, like, instead of whole numbers, like 5/4 of a minute or anything like that, or decimal portions of the minute as well. Now, here's the thing when it comes to it. So let's suppose I have 5/4 minute, like that, okay? So the way we write this is just like if you see this as well. It's 5/4 to the 5/4x. What that means is the variable and also the unit is always in the numerator, meaning the top number, okay? So for example, 5/4 minute, technically it means 5 minutes over 4. Okay, so the unit will always go to the top number if it's written like this as a fraction format. Okay, you see this a little bit in this section. I usually give you in decimals because that's far easier to understand. But some hard problems are going forward as well, right? They give you, a fraction and then the unit wise, but just be aware the unit always goes to the top number itself, not the bottom. Okay. All right, so just do a couple examples here as well. So first example is, how many inches are there in 4.5 feet? Well, this is what we're given. All right, so again, equivalency times what gives me inches is what I want. Well, let's see. There are 12 inches for every 1 foot, so we're going to be using that one now, right? So again, the question now becomes, what goes on top and what's on the bottom? So hopefully you guys can kind of get it, right? If you have feet on top, therefore feet must be at the bottom, because that's the only way to cancel feet out. So therefore, by default, inches has to be on the top, right? Again, it has to be one or the other. Okay. So therefore, we know for every 1 foot, there are 12 inches, right? Just going by our equivalency. Those cancel, and now we just multiply. So this is going to be 54 inches. And there we go. Okay. So why don't you guys pause it real quick and try the rest. At 4, 5, and 6. We'll do 7 together for the example, but try 4, 5, and 6. So I'll give you a quick 3, 2, 1, and pause. 3, 2, 1, pause. Okay. All right, so hopefully you guys try them out. So now let's do them together, right? So we want to go from minutes to hours. So it's actually the same question we did earlier, right, for the part B portion. So we're given 247 minutes. Well, our conversion here to hours minutes is there's 60 minutes in 1 hour. Minutes cancel. So now we just divide. So this is going to be 4.12 hours. And there we go. All right, so the next one. So this one's a little tricky when it comes to, actually 5 and 6 are pretty tricky based off that. So you see you guys are paying attention when it comes to it. So if a baby weighs 7 pounds, 9 ounces, what's the weight in ounces? Now, notice this is already in ounces, correct? However, pounds is not in ounces. So my goal is ounces total, right? We already part of it. So essentially, all we have to do is convert 7 pounds ounces, and then we're going to add the 9 ounces we self together. So what we're given, 7 pounds. So that's LB. Now, let's see. What is our conversion? This one you may not know. There are 16 ounces for every 1 pound. All right. Let's go back over here. So For every 1 pound, there are 16 ounces. So these cancel. So I multiply 7 times 16 is 112 ounces. And therefore, now I also add the 9 ounces as well when I started with, right? So a grand total of 121 ounces this baby weighs total. Okay. And the same thing applies for number 6 now. Now we're just talking about feet and inches instead of ounces and pounds, right? So convert this into inches total. So again, we already have inches there, so just convert the feet into inches. So we already kind of talked about this one. 12 inches for every foot. So this is going to be 36 inches. And then add also the 9 extra inches on top. So it'll be 45 inches total as this child is height. And there we go. Okay. All right, so now let's look at 7. So sometimes the question will actually give you the equivalency itself in it, and you have to use those when itself. So for example, number 7 says, suppose that the exchange rate in Spain is 0.746 US dollar to 1 Spain euro. From this rate, how many euro would be exchanged for 100 or 240 US dollars? Okay, now remember, we always want to write down what's given to us and what we want. So what we're given is that, right? That is our given. So $240 US. What we want is euros, right? That's what we want. This is what we're given. Okay. All right. So again, always start where we're given. So 240 US dollars. Okay. Now here's the thing, right? We said we always multiply by equivalency. And notice I didn't give you guys any equivalency when it came to currency, right? But this is where it comes in the problem itself, right? It says for every 1 euro, right, for every 1 Spain euro, it is 0.74 US dollar. There's our equivalency. So now we got to figure out what goes on the bottom top. Well, if we want to cancel out US dollar, therefore US dollar has to be at the bottom, which means it's going to be 0.746 at the bottom, and the 1 euro is going to be at the very top. And now this time we just divide. So 240 divided by 0.746 gives us 321.72 euros. So just in case you guys go to Europe or any equivalency, well, no one's going to Europe right now, but any travel, that's pretty much your exchange rate. So you can always figure out what you're going to get when it comes to currency or anything like that. Fun little question if you guys are things like that. Okay. All right, so now let's look at number 8. So this is what I was talking about earlier, is convert a multi-step process or a complex multi-step process, which means is you're going from you're not using one equivalency, you're using multiple equivalencies to deal with. Okay, so notice number 8 says convert 6 hours into seconds. Now notice we do not have a conversion from hours straight to seconds. We have to go bypass from portions to portions. But this is the same thing. This is our given, and this is what we want. Well, start with a given, so that's 6 hours. Well, the only equivalency we have roughly for 6 hours, or hours itself, is, well, days, which we don't want days, right? But we have minutes, right? So we know that for every 1 hour, there's 60 minutes. So we know for every 1 hour, there are 60 minutes. Again, right, hours has to go on the bottom. So we can do that to cancel out the hours. So if we multiply this way, that's 360 minutes. And now again, right, that's not what we want. We want a second. So therefore, I have to do another conversions. All right, so therefore, I keep multiplying by another conversion. Well, we know they are 60, for every 1 minute, they are 60 seconds. And now there is what we want, right? We have seconds at the very end. That's our units we want. And then finally, we just now multiply again 360 times 60, which gives us a grand total of 21,600 seconds. So again, that's called a multi-step process or a complex multi-step process, because again, we're using two equivalencies, right? One here and one there, like I said earlier as well. Okay. So let's try some more of these. Or actually, I want you guys to try some more of these. So go ahead and try 9 and 10 real quick. It's about the same concept we had earlier. 3, 2, 1, pause. Okay. All right, so hopefully you guys tried them. So we'll try them together now. So now it's the opposite, seconds to hours, right? So we're going to literally go the opposite direction we did earlier. So starting with what's given to us. So again, this is what we want. This is given. So the only equivalency we know is going from seconds to minutes. So these cancel. Which gives us a roughly 16.67 minutes. And again, right, we're not done yet, so we got to keep going. We know there's 60 minutes in 1 hour. And we get our final answer with hours. So roughly 26.94 hours. And there we go. Okay. All right, and then 10 is about the same, right? Now we'll just go from minutes to days. So again, this is given. This is what we want. So I'll just put G and W for short. So 45,000 minutes. Again, we don't have any minute to day conversions, but we know we can go from minutes to hours, right? And then hours to days. Sorry if you guys are going to sneeze. All right, sorry. So we know there's 60 minutes for every 1 hour. So divide this by 60. Gives us 750 hours. But again, right, that wasn't our goal. Our goal was to get to days. And we know there's 24 hours in 1 day. So then finally, just divide this again by 24, which gives us a grand total of 31.25 days. And there you go. Okay. All right, so let's go on to 11. 11 is a little fun one, just for fun when it comes to, you can see how this stuff changes around itself, okay? So 11 says, for a Super Bowl party, 30 people will be coming to Jeff's house. He decides to buy hamburgers for the people. He knows each person will eat 2 hamburgers. How much will he spend on food if a package of 8 hamburger patties costs $6.50? So a lot of information is actually given to us. So let's just write down, or the equivalencies given to us in this case, in the question, right? So we're given 2 equivalencies. The first one's there, each person. So for 1P, I'll just do 1P. 1P equals 2, we'll say H for hamburgers, right? 1 person, 2 hamburgers. And we're also told this right here. 8 hamburgers patties cost $6.50. So we know 8H is equal to $6.50. So notice the only thing we haven't talked about is the people, right? So that actually is our given, G. And what we want is how much he spent. So spent is price, right? Money-wise. Okay, so let's go over here. Always start what we're given. So 30 people. Well, now we go into conversion. So what's the only thing we have to get rid of P? This one, right? So we know for 1P equals 2 hamburgers. So those cancel. That's going to be 60 hamburgers, right? Okay, so we use that one, so I'm just going to cross that out. We used it already. So again, how do we go from H to money? Well, we got the conversion here. So very similar to the one we just did above. So we know 8 hamburgers is $6.50. So there we go. Now, when it comes to we have numbers top and bottom. First multiply, remember, when it comes to multiply fractions, you multiply across, right? So for example here, 60 times 6.5 gives you $390. over 8. And now we just divide that portion. Divided by 8 gives you $48.75. And there's your final answer if Jeff had to pay for the total price of food. Okay. All right, next video we'll talk about the rest of the examples.